Okay, so 7.1 was about solving all the pieces of a right triangle. 10.1, the law of sines, allowed us to solve an oblique triangle as long as we had a full opposite angle, opposite side pair. Now, in real life, we might not always have those conditions perfectly right. So the most complicated formula in many respects for finding missing pieces of a triangle is the law of cosines. Now, because there's no particular right triangle, and we usually associate the a squared plus b squared plus equals c squared, the c as being our hypotenuse. In this particular case, a, b, c is arbitrary. You can pick whatever you want. So the formulas that you see here are in 3 different patterns based upon the fact, what did you call A, what did you call B, what did you call C, because it doesn't really matter. The one that most resembles our Pythagorean theorem is this one, okay? In a right triangle, it actually becomes the Pythagorean theorem because the cosine of 90 degrees is 0, so that piece isn't even there. So I'm going to write the one that's most important. Yes. So the one that most resembles and the one that I memorize is this one. Okay, so how do you, all of these formulas are exactly the same, okay? This is across from that, okay? So in all of them, A, B, B, C, C. So these two have to be across from each other. These two are the other side, which you also see right here. So look here, other sides, B and C, BC's here. Other sides, AC, AC's here. So if you start out with A, then B and C has to go there. If you start out with B, then A and C goes there. If you start out with C, then A and B goes there, okay? So these two appear right here. So this formula does not have the limitations that the law of sine has. But it can be very easy to mess up the order of operations. So I'll kind of give you some hints as we go along the process so that you are less likely to mess up that order of operations, because it is so absolutely easy to mess it up, okay? So as long as you have any 3 pieces, and so this is what I do. When I see a triangle that's not a right triangle, I look, do I have that opposite pair that I can use the law of sines? Oh, crap, I don't. Then I have to use the law of cosines. You only have to use the law of cosines once, because as soon as you use the law of cosines, you'll get an opposite pair, and now you can use the law of sines. So never use it more than once, because it can be so weird, okay? So let's go ahead and look at an actual example, and then we'll see what we're talking about. Now, my triangle will not be to scale. I always think of it, I'm just going to draw a triangle that's kind of my placeholder of information, okay? So don't expect this triangle to be to any scale. Okay, so we have a triangular area of a lawn. There's a sprinkler located at each vertex. The sides of the lawn are 19, 24.3, and 21.8. So I'm just going to draw a triangle, kind of make it oblique, because that's, what this lesson's kind of about. I'm going to put where I just happen to draw the triangle. The littlest side is 19, so I'm going to put the 19 here. So that means that I have big A's right there, okay? The largest side I'm going to put here just because of the way I drew it. So that means big B is up there. And then the medium side looks to be about right here, which is C. So I'm going to put big C right there. Okay. It says, what angle of sweep should each sprinkler be set? Now, because we're giving 3 sides of the triangle, if you try to check a squared plus b squared does not equal c squared, so it's not a right triangle, we are forced to use the law of cosines. Because we're so used to saying the Pythagorean theorem is a squared plus b squared equals c squared, I'm going to start with c squared. So then I usually do that. So little c squared is a squared plus b squared, just like normal. minus 2AB cosine of angle C. Okay. Now, I just put the little degree measure on there to just remind you that that big C is an angle. Okay. Okay. So now let's take the information that we have and let's plop it in. Okay. So little c was 21.8. Little a is 19. Little b is 24.3 minus 2 times a times b. Okay, I'm going to pick this up, scooch it down here so I have more room. Cosine of angle C. So you'll notice that the only thing missing in this is the cosine of C. Now, I'm going to tell you some hints so that you do not muck this up, because it's very, very easy to just mess the whole process up. This is one term. The negative 2, 19, and 24.3 are attached to the cosine of C by multiplication. The only way we can get rid of that is division. Okay. Now, I'm going to just make up a problem to illustrate a point. Okay. If I had an equation, let's just look at an equation for a minute. If I had an equation that 4 equaled 7 minus 2 plus 2c. Think about what we're allowed to do to solve that equation. We can put the 7 and the 2 together, right? We can then subtract 5 from both sides. Then we can divide by the 2. Do you see how the coefficient on our C is the last thing I'm allowed to take care of? So that has nothing to do with this, except it's just kind of an illustration of the rules of solving equations that kind of might jog your memory a little bit. Okay, so that being said, here's my suggestion on how not to mess this up. Find out on a calculator what is 21.8 squared. Find out on a calculator, unless you can do it in your head, what is 19 squared. Find out 24.3 squared. 590.49. Do negative 2 times 19 times 24.3 and set that on the cosine of C. Okay, this is still stuck together. So just like this equation up here, where I can put the 7 and 2 together and then move it, I can put these two together and then move it. This is its own independent thing. Some people want to try to subtract off 92.3.4. I don't know, you can't, because it's 923.4 times whatever cosine of C is what you're subtracting. And if you don't know what the cosine of C is, how can you subtract something that you don't know what that value is? So don't. Okay, that being said, let's now combine 361 plus 590.49. And so we get 475.24. Sorry about that. 475.24 equals 951.49 minus 923.4 cosine of C, again, which is one thing. So the next thing we can do is subtract off 941.49 from both sides. And if we do that, wait a second. So 475.24 minus 941.49 equals negative 466.25 equals negative 923.4 cosine of C. Now we're going to divide off the negative 923.4. Now here's where we are going to Now we are going to need to divide both sides by negative 923.4. Now, you're going to get such a funky decimal at this answer. I would not, 49, I'm sorry, it's 49. 49. 49. 923.49. Yeah.
I got 476.
No. Oh, okay, so it's 476. I'm sorry. I'm going to trust you guys. So this is 76. So 475.24 minus 941.49. I got 466 again. Did I write something down wrong? Oh, because I wrote down 941, not 951. Thank you guys. I appreciate you helping me find that. Okay, so that's 951, which would make this 76. Yeah, okay, thank you. So now, okay, two negatives make a positive, so we don't have to write that again. Let's just leave this as a weird fraction. Oh, I did it again. That's a 4. That's a 4. I'm doing good. Let's just write that as a positive, just so we don't have to worry about that. Okay. So now we have this fraction. Now, it should always be for a cosine a proper fraction. It can be positive or it can be negative. It doesn't matter that part. But it has to be proper because a cosine and a sine is always either opposite over hypotenuse or adjacent over hypotenuse. Hypotenuse is always bigger than the opposite or adjacent. So you must have a proper fraction at this point. The top always has to be smaller than the bottom. That being said, it looks like we're ready to go. Remember that the angle is always going to be the inverse cosine of that fraction. Now, that means that's the only time on our calculator that we hit the second button. So that -1 notation should appear. Make sure your calculator's in degree mode. You're going to hit second cosine. So that little -1 appears. Only when you're looking for an angle do you hit the second button. And then you're going to type in the fraction, 476.24 divided by 923.49. You're going to get rounded to the nearest whole degree because that's what we've done so far. That C is 59 degrees. Okay, so let's go up to our triangle and put right here 59 degrees. So the law of cosines is tough. You can see it's easy to make mistakes. You have to follow order of operations and all that other stuff. Okay, everybody good so far? Okay, yes. Yes. It is 4. Okay, well that's going to mess me all up, isn't it? Okay, so that's 0.4. Thank you. That's 0.4. That's 0.4, 0.4, 0.4. It might change my degree a little bit. Thank you, I appreciate that. Okay, so 476.24 divided by 923. Everything was 2 decimal places, so I thought that one was too, but it isn't. Okay, so no, it doesn't. It's still 59. The decimal was a little different, but not much. Okay, thank you, though. I appreciate that. Okay, so now we've got angle C. So as soon as you do the law of cosines once, you end up with an opposite side angle pair. So now we never have to do the law of cosines twice. We can now do the law of sines. Now let's talk about how we do the law of sines for this. We know that C has been found, that opposite pair with 59 degrees and the side 21.8. So we can do the sine of 59 degrees over 21.8 is, let's just go the sine of A over 19. Now, you could have just as easily done B. It doesn't matter. Now, 19 is our smallest side, so we should get an angle less than 59, okay? So we just need to cross multiply by 19. So we know that the sine of 59 degrees times 19 over 21.8 is the sine of A. So remember, A is going to be the inverse sine. That's the only time we hit that on our calculator, of the sine of 59 times 19 divided by 21.8. Sorry, I've kind of run out of room a little bit. Okay, so the inverse sine of the sine of 59 times 19 divided by 21.8 is 48.3. We'll round that to the nearest degree. That's 48 degrees. Now, as soon as you find two angles, the last one you can find just by doing the 180 rule. So angle B is 180 minus 59 minus 48. So 180 minus 59 minus 48 is 73 degrees. So let's go put that stuff back into our triangle. So angle C was 59, angle B was 73. So that's 73. Angle A is 48. And then let's do a little quick check. The smallest side is across from our smallest angle, check. Medium side is across from the medium angle, check. Largest side is across from the largest angle, check. So doing that just quick little check is really a good way to find your, if you made a mistake or anything. So let me just kind of summarize what we just did. We found the law of cosines helped us find a missing angle. As soon as we found the missing angle, we had enough information to now use the law of sines. So then we use the law of sines. Once we do that, we have 2 out of 3 angles, then we can just use the 180 rule. So that's very often what's going to happen. You can use the law of cosines. You only ever have to do it once. You can do it more often, but it's you can see a very long process. Then you can do the law of sines, and then you can do the 180 rule. Okay, so that is our first example. You can tell one of these problems takes a lot of work. Okay. Do we have any questions about what you see there? Okay, now let's take a look at this one. Do you see how they say to solve the triangle? Now remember, anytime they use that language, they are asking us to find all missing sides and angles. Okay, we're going to round sides to the nearest tenth and angles to the nearest degree. If they don't say otherwise, that's the kind of rounding I want you to do. The first thing I always check, do we know if it's a right triangle? No, can't use the trigs. We can't use the Pythagorean. Do we have an opposite pair? Well, these two are missing something. This is missing something. This is missing something. So we cannot use the law of sines. So then you know you're resigned to use the law of cosines. Now, if we are given two sides and an angle like this, like a side angle side configuration, we have to start our formula with the side that's opposite it. So let me write down the formula we're going to use for this particular one. So it's going to be a squared equals b squared plus c squared minus 2bc cosine of angle A, because we must have the only angle showing has to be here. And remember, these two go together. These are the other sides. These two go together. These are the other sides. So if we're only given information about one angle, That's the angle we have to have showing up in our problem. Okay. Now that we've done that, let's go ahead and plop the information into our formula. I don't know what A is. B is 12. That's the one across from B. C is 14. That's the one across from C. So put your 12 and 14 where they go. And in this case, we know that the cosine of angle A is actually, we've been given angle A as 39.4 degrees. Now, the first example, when you are missing the angle, is the hardest one to compute. The one where you're missing a side across from an angle, it's actually a little nicer. Okay, so let's mathematically do what we've got to do. So 12 squared is 144. 14 squared is 196. Negative 2 times 12 times 14 times the cosine of 39.4. I have to do that separately. That's minus 259.64. Now it says our final answer is rounded to the nearest tenth, so I at least go out one extra place and don't round until the final answer. Or sometimes I'll even write more than that. Okay, so now if you combine all that stuff, we get that A squared is 80.362. And if we take the square root of that, we get, when rounded to the nearest tenth, because it's a side, it is 9.0. Now, of course, you could just write 9, but they said to the nearest tenth, so I'm just showing the tenth spot. Okay. Now, we have a cross pair. If we know that that's 9, we now have a finished cross pair. You never have to use the law of cosines twice. You only ever have to use it once. Now we are allowed to use the law of sines. So I know that the sine of angle A over A is the same as the sine of angle C over C. Now you could just as easily written B over 12. That works as well. I just use C. So if you cross multiply with the 14, I know that the sine of 39.4 times 14 divided by 9 is the sine of C. How do we enter that into a calculator when we find an angle? What button do you have to push if we're looking for an angle? The second button, remember? Yeah, the second button, or sometimes it will actually say inverse INV on some calculators. But if you're looking for an angle, we have to hit the second button. So the angle will be the inverse sine of that stuff. The sine of 39.4 times 14 divided by 9. Okay. And you can just put that whole darn thing in. So if you hit second, then sine, that little negative notation comes up, times the sine of 39.4 times 14 divided by 9. And the angle measure when rounded to the nearest whole degree is 81 degrees. Okay, so let's put that on our picture. And as soon as I know 3 angles, or 2 angles, I can find the third using our 180 rule. So I know that angle B is 180. Why did they make it 39.4? I was just thinking of that. If they want us angles to go to the nearest degree, whatever. So anyway, 180 minus 81. I'm just going to put minus 39. Shouldn't change much. Anyway, 180 minus 81 minus 39 is angle B is 60 degrees. Okay, so now let's revisit what we have found, and does it go together, and does it logically make sense? Our smallest angle 39 is across from our smallest side 9. Our next smallest one is B. It's across from the median. That's good. And our largest side is across from our largest angle. So again, that is just such a helpful trick, because if you just check that very thing, you'll probably find if you've made a mistake. I'm not super concerned that you have rounded, because if you round earlier in the stage than I did, you might get a slightly different answer, but I should expect we should be 1 degree off at the very most, probably, when it's all said and done. So as long as you're close, even on a test, I'll allow for a little wiggle room as far as the rounding. Do we have any questions about what happens if the three things looks like this, where we have a side, an angle, and a side? Okay. A formula that results from the law of cosines is, if you know the lengths of any three sides of a triangle, it doesn't have to be a right triangle. You don't have to know the height. We're used to the area of a formula, or the area of a triangle, being 1/2 base times height. Finding the height in a real world situation can be very difficult. So, what is that perpendicular height of one of the bases? That could be very funky. So that leads us to a really cool formula that can find the area of a triangle as long as we know the length of the three sides. Okay, so the first thing you want to do, step one, is you want to find S. It's called the half perimeter. So you take half of the perimeter of your triangle. So this triangle has sides A, B, and C. You find half the perimeter. The second thing you do is you use this cool area formula. And so it's just S times S minus A times S minus B times S minus C. You find that calculation and you take the square root and you got the area, which is very cool. If it's not a right triangle, if it's a right triangle, I'm going to use 1/2 base times height. But if it's not a right triangle, this formula works. It's really kind of cool. You may have not seen Heron's formula, but I always found that's just kind of a neat formula. Okay. So that being said, let me show you an example of that formula in use. Okay. So somebody asks you to find the area of this triangle. You have measured all three sides. You used a measuring tape. You measured all three sides. Maybe let's think of it's a section of a lawn that happens to be, maybe a road and your driveway and, something else. And you need to know, you're going to buy grass seed for that. So you need to find the surface area so you know how much grass seed to buy, okay? Well, normally we would have to find the base and the height. We don't have that information here. So instead, we can use Heron's formula, okay? So the first thing we're going to do is we're going to find that half perimeter. So in this particular case, S is half of 44 plus 47 plus 53. I don't think I went in ABC order, but just find half the perimeter, okay? So the perimeter of this, if you do 44 plus 47 plus 53, is 144, and half of that is 72. Okay, so our half perimeter value is 72, and 72 and all the other sides. So let me label them. This is A. It doesn't really matter, really. This is B, because remember, A, B, and C are arbitrary for a non-right triangle. Anyway, now let's find the area. And it says to round our answer to the nearest tenth. Okay, so it's going to be the square root of 72. 72 minus 47 times 72 minus 53 times 72 minus 44. So you're just doing 72 and then multiplying that by each quantity of 72 minus all three sides. Okay. Okay. So the area is 72 times 25 times 19 and 28. So 72 times 25 times 19 times 28. I mean, you can enter that into a calculator. Is 957,600. And if you take the square root of that value, you get that the area is 978.6 square feet. And if they've provided units, please provide units yourself. Okay? So, just kind of an interesting formula that I wanted you guys to see. Kind of an interesting way. If you ever need to find the area of a triangle and it's not a right triangle and you know the length of the sides, bam, there's actually a formula for that. Okay? And someone derived it using the law of cosines. That's why it's in this section. Okay? Any questions on how we use Heron's formula? Kind of a neat formula. I like it. The first time I saw it, I was like, oh, I didn't know that formula existed. Like, oh, that's a cool one. So there's actually one that goes along with the law of sines, but I don't think it's because it still looks like 1/2 base times side. So anyway, so let's talk about these problems. Okay, problems 27, 28, and 29 says to solve the triangle. Let's set up 27 just so we kind of have it. Just make an arbitrary ABC triangle. It doesn't have to be to scale unless you want it to be. Angle A is 42 degrees. Side B is 12. Side C is 19. So to solve the triangle, you're going to have to, it's like example, the one that was labeled, I think, example 5, maybe it was the 6th one, where we have a side angle side kind of combination. We can find side A very quickly and go from there. Okay, so I expect for 27, 28, and 29 that you draw the picture and then you solve for all the missing parts. Okay, 37 and 38, you don't have to draw the picture unless you have the urge to. But there, please use that Heron's formula that we saw on example 7. And then 52, all you're going to do is use Heron's formula 3 times, find the area of that triangle, find the area of that triangle, find the area of that triangle, add them all up, you got the area of the funky shape. Okay, so you have until, and I'll check the deadlines if I haven't marked them correctly. You have till I see you at the beginning of class on Monday to get this turned in. Work now where it's fresh in your mind. And I will post this video if you need to see it at all in the future. Okay, so there you go.